Okay, we're back. So in this new video, what we're going to do is run the previous simulation, but outside this Workbench bubble. This is the way I like to do it. So to do that, remember that as you go back in the directory, in my case is saving everything here in test files. So as you go back here, you can copy all those files. So remember that you have DP0 here, and in sys1, here you have the mesh. So let me create a new directory to put everything. So I would call it new. Okay, not very intuitive, but put it there. So let me copy. This will be the clean mesh. Okay. Then remember the properties option in the Workbench. You can see where it's located. But here in Fluent 1, you have all the case setup. So this one is the one that you can copy the settings. And here you see that you have the final solution, okay, the .dat, and also the setup. Okay, so let me copy these two also just to show you. Okay, so I copy my files. Okay, so at this point, let's do it. The mesh from scratch using the settings to set up, and then I'm going to start. I'm not going to run. I'm going to start from this case just to show you. So if I go here, that have here the student version, it is Fluent. Okay. And remember here you need to define if it is 2D or 2D. In our case 3D, double precision, 4 cores, and then let me give the directory, the location. It's located here. Okay, so we're going to enter here. Okay, so Fluent is launching. So see that, but it's very important that when you have the single, the standalone Fluent version, you are not using all those options in the Workbench. You are saving a lot of memory. Okay, so this is why I recommend you are saving a lot of memory. Okay, and honestly, you need to get to have all those options in the Workbench unless you are interested in doing parameterization or optimization. Okay, but if you are running single simulation, it's better to go into a stand-alone Fluent. Okay, so for instance, go here, read mesh, and see that get the mesh, reading the mesh. Okay, and we have it there. So if I go here and let me plot the mesh, so it's like zoom in. Okay, edges, you select edges there and you can see the edges. So these arrows mean this is the inlet, and the other one, this is the outlet. Okay, so you have everything there. Okay, so and then remember you can go here, evaluate mesh qualities. You want, you can increase the quality, and you can check here the info, the mesh size, also the scaling. So always check this, okay, in 3D that you have the right dimensions. So if we want to run this case, remember that we put here the settings files, this one that you generate in the Workbench. So if you want to reuse that settings, you go here in the text user interface. So you can redo everything manually. Okay, there is no problem, it's up to you. But we have that file, so we can reduce that file. So it's file, enter, and see that is this option, read settings. Okay, so you go read settings, and the name of that file that is called sys-1set. So sys-1.set, and it's reading that setting automatically. Okay, and it's doing the setup, everything. And at this point, we're ready to go. We have everything. So as you start to look here, you will see that you have all your setup, everything have been defined. You have all your monitors. So at this point, you're ready to go. You go here, right? You call it, let me call it new. And as you press initialize, you choose your initialization. Okay, you are ready to go. Okay, so I'm not going to run this one. We already run it. We know the outcome. And here you run. So what I want to do now is just to show you that you can open some of the solutions. So see here that when we run the previous one, we save this one. This is the latest time. So you can open that one. So let me go here, read, and let me read the data. Okay, so you read this one, deduct that. There you have the last solution. Okay, so I can read that one directly because I know that the mesh is the same. So this mesh corresponds to the same setup. But if you have different setups, it's better to read also the corresponding cast file. Okay, so actually the proper way to do it will be read cast. This is your case. So remember, in the case you have your mesh and case set up. So kind of the same stuff like we did when reading the mesh and then reading the setting, and then you read the data, and this is your last data. Okay, so if you go here, you will see that we have a solution there. Okay, so it's totally the opposite. And you can go here and you will see that you have the monitors. We can plot the monitors. We cannot plot this one because we didn't save the text file, but if you save the text file, you will be able to plot those two. But we saw that the y plus value was still oscillating a little bit. So let's keep running this simulation. So see that we don't need to start from scratch, where we start from this one, the save it solution, and we can iterate. And so let's run from that latest state. So residual, let's switch off our residuals. Okay, everything switch off and run. See that I don't need to initialize because I already have a solution. I go directly to run, and let's run 100 iterations. If I press calculate, and you see that all the setup, all the previous setup, you keep it. So as you go here, you will see that still you have the 100 saving frequency, everything. Okay, you don't need to redo anything. So you press calculate, and now you're going to run starting from the latest state, from the state that you saved it, this one. Okay, you see that it's starting from there. So very helpful also. Okay, you need to start to go back to 0, just get the latest time step and keep running. And in principle also you can do this one using different meshes. So you can run in a quartz mesh and then interpolate the solution to a finer mesh and different domains. You can do everything. Okay, so those are advanced options that I'm not going to show you here, but if you want to discuss that, let me know. But there are many advanced options. Okay, so see here that imbalance close to 0 as we should expect, but see that this one, the y plus, is still it was oscillating a little bit. It's small quantity, but it's still oscillating. But remember, this y plus is also a direct indication of wall shear stresses. So let's see what happens when we run 100 more iterations. Okay, if these oscillations are reduced more. Okay, so see that, monitor everything. So as I told you, that this is not a direct indication, it's a good converge solution. So maybe you have reached the 10 to the minus 3, criteria that you set, but this one still was oscillating. Okay, so now we let it run. Okay, we switch off this tolerance value, and then we let it run to the maximum number of iterations. Okay, to see what happens. But again, as I mentioned, this is not a direct indication. It is a good indicator, a good metric, but do not rely 100% of this. Always check some other metrics, that these metrics might telling you more about the behavior, what is going on in your simulation. So maybe let me go here and see that I have subwind and view, and I put everything there, and I don't want to see this one here. I want to see this one. Okay, so I have all my windows there, and see that you have all your monitors here. Okay, residuals. Okay, the y plus value and your imbalance. So here at this point, is saving the solution at 200. So as you go here, see that you should have, okay, the 200 y. I don't see that. Okay, probably it saves that. Okay, so see here that it saved that file. Okay, let me, later I will stop, but see that it saved it in this location. So I forgot to update that But if I go here, see here that you have the 200. Okay, but I forgot to update that location. So these are small stuff that also you should be aware of. So okay, arrive here 100 iterations. So see here that it saved the solution in this location. Okay, but it saved it here because I forgot here. When I go here, see that if you open this one, see here that in browns you have this location. So usually also it's a good idea when you're moving files, always check everything and put it in the new location. Okay, but here is the location where it's saved, so always check everything. Okay, so write case data. So let me write this one, it should be new here, and I call it new. Okay, and this is the solution. So see that this is a much better solution than the previous one. Okay, let me tab view. So see that it's starting to become flatter here. You don't have any more of those oscillations. You can look at your solution. So it will be, let me rotate it like this. Okay, so see that you have it there. Let me change the light in here. Okay, so there's a little bit more advanced options. So always I will show you a little bit more, but just feel free to browse those. So see that you have your velocity profile. You can change whatever you're plotting there. So for instance, pressure, put it there, turbulence quantities, turbulent kinetic energy, and as we spec here, remember that you have here the wall function and you have this behavior. Okay, so at this point, what I want to do, so the next step will be here, do this plotting. Okay, so we're going to do this plotting outside Fluent. Okay, so how do we do this? So this is very straightforward. Okay, so remember that to do this plot, okay, you need to sample the wall shear stress at a location, and also in a line you need to sample velocity, and using these values you can compute all these quantities, you are ready to go. So in my case I'm using Python, but if you want you can use MATLAB, NumPlot, whatever you want, even Excel. Okay, it's up to you. So let me show you how to do that. Okay, so remember in Surface you create that line. Okay, so I created here in this case, so you know your reference system, you put it. Okay, so remember that line needs to be normal to the point where you are located sampling. So if you are sampling here, needs to be normal to that location. Okay, so I have that line, I know it's normal, everything is okay. So you go here into now plots, it's Y, and you choose whatever you want to save. So let's say that first I want to save velocity. Okay, so see that you have your velocity profile. Remember here you can choose if you want cell center, you deselect that, cell centered, you put it here, no centered. So usually when you're saving the data, it's better to save no centered. Okay, but not much change. So see that there is a difference between the profiles. Okay, no and cell centered. Okay, but at the end of the day you get the same solution. Okay, but usually I recommend you to get no nodes values. Okay, select the line what you want to save, and then order the points right here, and then give it a name. So I would call it, usually I would call it, I don't know, velocity profile, and then save wall shear stress, wall fluxes, WS, and that's all. That is the only information you need. So if you go back here, see that you have these two text files. You open this and this, you have all the information along that line. Okay, so see velocity profile, you have all that information, and then the wall shear stress. So at the wall, this is the wall shear stress that you are going to use. Okay, so at this point, let's do that post-processing in Python. Let's move to Python. Okay, so we're going to read this file Okay, so you save it here. But before moving there, okay, let me show you. Well, okay, now let's do it also in the next tutorial, how to do it also here, okay? So we are also going to do it here in Fluent. Remember that in Fluent, you need to create here the custom field section. So we're going to create those custom field sections in Fluent. So we're going to do two things in Python. Okay, so we're going to, in the files, okay, in the data that you downloaded, okay, so when you download the cases from the website, see that you are going to also, I'm going to put a link to download this plots data analysis, okay? So you can download this information, and this one. And here you already have all the files, okay? So you have this directory where here you have the Python script to do this plot, okay, different data, okay? So you see that here you have this Python script or the Jupyter notebook. See here that already saved the data in the line and that location. So you have velocity and what shear stresses. As you go in data plot, you have some other plots. So here you will find these plots, okay? So turbulent and laminar flow, okay? And then you enter in that subdirectory, you have different plots, so you're going to find these plots. And what is interesting here that I want to mention, see what the difference. This is a laminar case, but in this profile, that the orange one, see that the turbulence model was enabled. And this is what I told you, that it's not a good idea to run a laminar case with a turbulence model enabled, because it may happen that it might add some diffusion. Like in this case, it's adding some diffusion, that is something, it's a large value, it's like 10% that you are changing the velocity there, okay? So you have all the information. So if you enter here y+1, as you open the case files, you see the description yp1 correspond to these values and so on. So but basically what I'm saving there, so you enter into any directory. See, you have L10, this is the velocity, so this is the velocity profile, and WS, this is wall shear stresses. Okay, so using this information, we are going to construct these plots. Okay, so we only need to sample what shear stress here, compute shear velocity, then with shear velocity, compute y plus along this line, and then also u plus, you compute it like this because you sample u along this line, and then put everything there. Easy peasy. Okay, so I think that is all for this case. Okay, so now let's move to the advanced plotting. Thank you for your attention. See you next video. Bye.